Hi everyone, Engineer Liu here. So this will be our 13th video on our series of videos on the C programming language. And on this video I would like to talk about a topic which caused a lot of people a lot of confusion and doubt, which is recursion. Of course, what we'll talk about here apply to other languages as well, but I will be applying it specifically to the C programming language. And for this example here, I will show an example of recursion using to compute the factorial of a number. For those that you don't know what a factorial is, basically, it only works for integers, positive integers. So for example, if you have n, it will be n times n minus 1 times n minus 2 times n minus 3 and so on up to 1. So here, for example, if we have a factorial of 3, we use the exclamation mark for denoting the factorial. It will be 3 times 2 times 1, which equals 6. And for 5, we have 5 times 4 times 3 times 2 times 1, which will be equal to 120. And by definition, factorial of 0 is 1 and factorial of 1 is 1. This is used a lot for combinatories and computing permutations and also various applications in probability. And here I already implemented the factorial function without using recursion. So as I mentioned, it only works for positive integers. So I declare it to return an unsigned int, and it receives an unsigned int, which is positive integer, as I mentioned. And so it checks if it is equal to 1 or 0, it returns 1, and if it is equal to 2, returns 2, and then else it does this while loop here. It will keep decrementing y until while it is greater than 1. And here on the main function, I call the factorial function right here and ask it to compute it for the first from 0 to 9. And what we got here is 1, which is a factorial of 0, 1, which is a factorial of 1, and 2 times 1 equals 2, 3, which is 3 times 2, which is 6, and then 24, which is the factorial of 4, and 5, 6, and we can check that. I will check that with the Python, I believe from import math.factorial. Okay, so let's check a factorial of 3, it's 6, 4, 5, 120, 6, 720. So it seems correct. As you can see, the thing with factorial is that it increases really fast, so on most computers and calculators it will crash when you try to compute factorial such as 12 or 15, most cases 20 sometimes. So let's check it with Python. 13, yeah, we are getting there. 15, 16. Yeah, I believe we are. Let's try, I don't know. Yeah, this is probably an approximated case, but yeah. So how would we implement that using recursion? Well, recursion basically is calling a function within itself. So you're running a function and then you call a function inside itself to So why would we do such a thing? Basically to write more efficient algorithms and minimize our time complexity. Okay. One classic example of algorithm which uses recursion is the FFT, the fast Fourier transform. It uses, of course, there are several algorithms which implement the FFT, but the most used ones use recursion. Also, quicksort algorithms use recursion. So factorial is a very basic example of recursion, and we'll see how we can implement that. So we call the factorial recursive. Okay, and everything's pretty much the same. We return unsigned, damn it. Return unsigned int, and we got an unsigned int as an argument. Okay. And well, we do basically the same thing if n is equal to 1 or n is equal to 0. We return 1. Okay. Else we call it we return n times the factorial recursive of n minus 1. So here is the recursive part basically. So what will happen here? So let's try it. Let's go from 0 and going up. So if it is 0, it will arrive at this case, and then it will return 1. If it is 1, it also will go to here and then return 1. But if it's 2, it will go to this else here, so it will be 2 times the factorial of n minus 1. That will be 1. So it will be arrive here, and then it will return 1. So it will be 2. It will return 2 times 1, which is the factorial of 2, which is equal to 2. If it is 3, it goes to 3 times factorial of 3 minus 1, which is 2. And then it goes to here, it will be 2 times factorial of 2 minus 1, which is 1. And then it returns 3 times 2 times 1. Okay, so here you can see the recursive part. It will keep calling itself over and over until it converges to a certain condition, and then it will give the results. You have to be careful when using recursion, because you have to make sure that your function actually converges to a certain value or achieve some result, because it can keep calling itself continuously and never arrive at any result. And then basically you have an infinite loop, and yeah, you can end up crashing your machine. So, or worst case, freezing it. So let's call it factorial recursive. So it should gives us the same results. So let's call it both of them just for comparing. And factorial of I, let's say non-recursive, and then recursive. Okay, so we expect it to converge, and there we go. We got the same result for the recursive as well as the non-recursive here. 66, 24, 120, and so on. Okay, so why use recursion? So as I mentioned before, when basically it's a tool for decreasing the time complexity of an algorithm. So we usually use recursion to achieve more faster algorithms. So let's check if that's the case for this one right here. So let's measure the time for the non-recursive here. Oops. And for us to have a good sample, let's make it a compute like I don't know, I guess 10,000 times the factorial. It should be enough, I guess, for a good sample. So we'll need another variable here. So j equals 0, j less than 10,000, I think it's good. And then, yeah, we call it. So let's compile and run. Yeah, it was pretty fast. Let's increase this 10,000 to 100,000. Yeah, it was really fast. 1 million. Yeah. Yeah, it's slightly higher. Let me try 10 million. Yeah, no, I think it's good. So let's track it. So it's time for non-recursive. So it's around 0.7 seconds to compute. Okay, so let's try it with the recursive. Let's see if we have any difference in speed. Okay, 10 million times. Compile. Oops. Let's track it. Yeah. So in this case, recursion was actually worse than non-recursive. So it took 1.5 seconds to compute, while the non-recursive took like half the time, right? So it's not always that recursion is it's not always that if you have the option to use recursion like this, you should. It's not because that you can that you should do write your functions recursively. Okay, so yeah, that's why we always do some benchmarks like this to check if our algorithm is in fact more time efficient than the one than the other. Okay, so hopefully that this video answers some of your questions regarding recursion. I know it can be a little bit confusing at first when you're learning by the first time. So you should, if you want to learn more about recursion, should look into algorithms such as the quicksort algorithm, which uses or the bubble sort algorithm. One of them, I believe, or both, use recursion, and of course the famous FFT, the fast Fourier transform, which uses recursion. Okay, so hope you guys liked this video. Don't forget to like, subscribe, and comment. See you next time, and bye.